Hi everyone. It's good to see you again. I'm Will. Do you remember me?
Hi, it's Emma here. Let's have fun together today.
Hi everyone. Thank you for coming to Minpro today. Today we're going to talk about the computer's language.
Minpro.
Have you ever seen a movie featuring robots?
I have. It's cool how they manipulate the robot.
They were speaking human words.
What language were the robots speaking?
They were speaking human words.
No. There was some making electronic beeping sounds.
Humans can't understand those beeps.
That's right. Humans can't understand robots, or in other words, the language of computers. When we talk to computers, we use words called programming language. For example, Scratch language talks by combining blocks. But even programming languages aren't the computer's true words.
Then why do things move when we program with Scratch?
Well, Scratch replaces the blocks with computer words. The computer's words are called machine language or machine code.
I get it. Computers are people from the world of machines, so they speak machine language.
Wait a minute. Let me sort out what you just said. Humans program with Scratch, and Scratch changes that to machine language. The computer reads that language and calculates something. The answer is in machine language, so Scratch converts it into human language, and the humans can finally hear the response from the computer.
That's right. You understand it well. Programming language is an interpreter. We study foreign languages so we can speak them. But, humans cannot speak machine language. That's because the words are all zeros and ones. Remember I said that computers are calculators with only zeros and ones?
There's no way you can calculate with just zeros and ones.
What about the 2s to the 9s?
Well, let me explain about computer words, or machine language. Computers are machines that run with electricity. Electricity is either on or off. You use a switch to turn the lights on, right?
That's true, but
Computers aren't lights.
They aren't lights, but they have many switches that operate with electricity. These switches are made of components called semiconductors. They are very small, with more than 1 million mounted within the size of a 1-cent coin.
What? I don't believe that.
It's true. Computers talk by operating many switches. There are on and off switches. These are expressed with the numbers 0 and 1. This world of numbers with only zeros and ones is called binary numbers. Machine language is a numerical language expressed with binary code. In comparison, the numbers 0 to 9 that we use are called decimal numbers. Decimal numbers start with 0, and after 9, the place increases by 1 to make 10. Binary numbers start with 0, and after 1, the place increases immediately to make 10.
it's already 10?
We read this as 10 instead of 10. 10 expresses the decimal 2, so it is not called 10.
If 2 is 10, then what is 3?
That's a good question. 3 is 11. 4 is 100.
It's like a quiz.
If the digit place increases so quickly, then how do you express 10,000?
10,000 is 1001110001000. There are 14 digits, but the computer works really fast and can handle them.
This is difficult for humans. Is there no word for place? Like tens or hundreds?
There are words such as kilo, mega, and giga used for every 1,000-fold. There's also a system that's easy for humans to understand. It's called hexadecimal and groups binary numbers in batches of 4 digits. There's also a system that's easy for humans to understand. It's called hexadecimal and groups binary numbers in batches of 4 digits.
I see.
In hexadecimal numbers, 10,000 is represented as 2710.
It's 4 digits.
It's still read in the same way.
Incidentally, 100,000 is represented as 186A0.
It's a really computer-like number.
Words in machine language are numbers that are arranged in this manner. Commands such as calculate 2 plus 3 are given inside these numbers.
How does the computer distinguish words and numbers to calculate?
Words and the numbers to calculate are both binary numbers. The difference is the location in the computer's storage device called the memory. The memory is like a notebook. The first page of the memory is for words, and the second page is for numbers. Words are also called code, and numbers are called data. The computer reads the numbers on the first page as codes and the numbers on the second page as the data to be calculated. For example, the number 010000000 on the first page is code that means add 1. The same number on the second page means 64. The inside of the computer is a simple and mysterious world of zeros and ones. We don't need to know anything about machine language or binary numbers, but it is important to understand our computer partner as well.
Well, we can't get along with people we don't know, can we?
Let's talk about binary number calculations another time.
What programming languages are there other than Scratch?
Let's see. There are many languages other than Scratch.
Just like other than Japanese, there's English and Chinese?
Yes, the programming language is selected by what you want to achieve. Scratch is recommended when programming for the first time. The words are blocks and easy to understand. For machine programs, C language is often used to write the machine's movements in detail. The language called Java is used for web programs, such as for internet shops. Python is a popular language for programming AI, or artificial intelligence.
Who is it popular with?
With programmers, the people who write the programs. For example, they write these kinds of programs.
It's all English and symbols.
I can't read this.
These are words that you can't use unless you study properly. But, they allow you to talk and give details to the computer. Programmers are people who study these words and can have complex conversations with computers, aren't they?
Do we have to learn a lot of programming languages?
Not really. You just need to learn the words you need for your intention.
Phew. I was a little worried.
Can we make games with Scratch?
You can create simple games. If you want to make a fantastic game, like the one you play on a gaming device, you need to learn other words. Will, I think if you study well, you'll be able to do it.
Can I? Yes, I can. Of course, I can. I can do it.
Good luck.
Minpro.
Since we talked about binary numbers today, let's look at programming using status variables.
What's that?
It's a program that observes the train's status when the start button is pressed and starts travel if it is safe.
It's like a game.
It's a type of simulation game. It checks the status of the train, or in other words, the status of the machine. This is called a status check and is always included in a machine's program.
The game status has various numbers, such as HP and MP.
With a machine, multiple statuses are often bundled into one variable. Let's look at the program for safely operating the train. This train has a door, brake, and signal statuses. These statuses are bundled into one status variable. The door status is the first digit of the variable. The brakes are the second digit. And the signal at the front is the third digit.
Why are these bundled into one?
That's a good question. When the statuses are bundled into one, it's easy to see whether the train can depart safely. It's safe when all 3 digits are 0, in other words, when the statuses are 0.
I get it. Instead of checking 3 times, you only need to check once.
That's right.
That's handy.
By bundling the statuses well, special statuses can be easily checked. Deciding how to bundle the statuses is also a part of programming. Let's try running the train program.
The status is 0, so it started well.
The driver confirmed before pressing the start button, so it's okay, isn't it?
Well, humans forget sometimes, and even if they do check, they can make mistakes.
Just like someone who forgets his lunch because he was almost late for school.
Well, that might happen sometimes, but...
The computer checks the status of the train together with the driver. 2 people are checking, so it's safer. The programming you will learn and create here is one of the methods used by computers in the world. Because there are so many machines and systems, there are many different ways to program them. If you study at our center, you'll learn more and more about such things. The knowledge you learn here and the experience of creating programs will be helpful to you when you grow up. Maybe you will have programming methods that are more convenient and easier to use.
I hope I can become a famous programmer at a game company.
I thought you wanted to become a YouTuber.
YouTubers don't do programming. I want to create programs.
Good luck.
There are various jobs, other than games, that require programming. You should look into them.
Okay, I'll do that.
In the next video session, we'll use a different method to draw polygons, which you learned at school. I hope you'll join us.
Bye.
See you.